Start-stop technology is a feature that most car owners really dislike, and it's something that's been going on in cars for some time. Well, hello and welcome to the Car Care Nut channel, and in today's video we're going to talk about how does the start-stop technology system works. In short, start-stop technology is you come to a traffic light, your engine shuts off. As soon as you take off, it starts, in case you were not familiar with this term. But the thing that most people don't know is they assume it just starter shuts off, starter comes on, and what's so special about it? But there is so much that had to change with cars to make that system work and work efficiently that we're going to talk about that and a lot more right after this. Let's start with the history of start-stop technology. Where did they come for that and how did that come about? Well, it actually stemmed from hybrids. They realized that in hybrids, hybrids normally will shut off and start the engine. That's just part of their operation. They realized that when these hybrids stop at a traffic light, they create zero emissions many of the times because the engine is not running. And they wanted to find a way to integrate that into gasoline cars, non-hybrids. The first thing is, what is the benefit of this start-stop technology? Most people assume it is for gas mileage, and it is. It does have a small effect on gas mileage, but it's so small, honestly, that you can't even tell the difference. But the biggest impact is emissions. People usually don't think about emissions. Emissions is the big thing. Here's a scenario to make sense. You got 15, 20 cars in a traffic light. They're all idling. It's very hot, the AC is full blast, and maximum load on this engine. All this emissions when you're stopped. But if all these engines are off, well, we have zero emissions. And yes, it doesn't make up for when the cars are running and all that, but it does something. And that's the idea here. Now, Toyota started with their start-stop technology right around 2017, but this information in this video will be somewhat about Toyota, but it can apply to other manufacturers because they all did basically the same thing. They did not just shut off the engine and start it and let's go. They actually had to almost redesign every single system in the car to make this work and work well, as you'll find out in the next section. So how does start-stop technology work? We're gonna do something that we haven't done in a while on the channel. We're going to keep things simple because they're actually a lot more complicated, especially in this one. And let us go back down memory lane to the day where the engineers that initially worked on this system and made it started planning for it. See, they were given a task. And in order to achieve that task, there has to be many obstacles and many problem after problem that they dealt with until they reached the final product. So if we take a normal gasoline car that doesn't have start-stop technology and simply just shut off the engine at a traffic light, here's the problem that you'll have. First, it will take the engine a long time to actually start back up, and then the transmission to reshift into drive, and then while you're waiting for all that to happen, your HVAC performance has dropped to almost nothing, and then we get going. See, that was too long, especially coming from, they're looking at a hybrid, how it does the transition. Because you have that electric drive in hybrids, it takes off, then the engine starts, and everything is seamless and basically there's no transition. They wanted to duplicate that so people wouldn't feel it like a burden. That was the whole thing. So they started with the first thing. Well, how do we make this engine start faster? And then there's times where you stop at a traffic light, the engine's about to shut off, and then you immediately start going. So how are you you have to wait for the engine to completely stop, then start it again. It's such a slow operation. So they started with the starter. See, in less than 30 seconds, here's how a normal car starter operates. You have a motor that's gonna actually spin the engine, and you have a solenoid. When you energize that solenoid, a little arm comes out. It energizes the motor and pushes to engage the starter to the engine. As soon as you let it go, this pinion gear, that is a little gear that engages on a flywheel, it comes back. That's why when your car is running and you try to start it again, it'll make a grind because that pinion is trying to go and it's not at the same speed of the engine. The engine's spinning at idle speed and this thing barely spins it at 200 RPM. It grinds on it. It can't engage because they're uneven speed. Aha! That was the first problem they had. Well, how are we going to do this? What if you're stopped in traffic and the engine is about to shut off, it's not shut off completely, and then you let go and you want to go? Well, how are we going to start this engine? That's the first problem. So they re-engineered the starter. They went to a tandem starter, and here's how that works compared to a conventional starter. So you have, instead of one solenoid that comes out, engages the motor, and then pushes the pinion, they have two solenoids. We have one solenoid only engages the starter motor to spin, and another solenoid that pushes the pinion gear. So if the engine is still spinning and you wanna, it's kind of like shutting off, and in the momentum of the engine to shut off, you wanna start it again, it will actually engage one solenoid, spin the starter motor to get it up to speed, then the second solenoid pushes the pinion gear in, and now we're at the same speed, it can start it back up. But then when we're in low speed operation, or basically this engine is stopped, they both engage, the pinion comes out first, then the starter hits it. That makes things a lot quicker. And this starter is a very heavy duty starter that spins very quickly. Some manufacturers have used a reduction motor, so it's a very torquey starter that starts the engine at almost idle speed. That was the ways they have done this. But then things got a lot more complicated. The new problem was, well, we have this fancy new starter that now draws even more electricity because it has two solenoids that need to activate, and it's very rapid and very quick. So here's what normally happens in cars. Some folks actually are not aware of this. The starter in a gasoline car is the largest load on the electrical system and the battery ever. It draws the most amperage out of any other components, or actually sometimes all the components combined, no matter how advanced cars get. So here's the problem. Well, when you start the car normally, you notice all the electronics are off. Once the car starts, they all come to life and everything starts loading up and booting up. And as we get into newer cars, there's a lot of computers that need a few seconds to load up and kind of start functioning. So when you do that rapid start, we're ready to go, well, there's going to be a huge dip in voltage on the battery. That's normal because the starter takes a lot. So how are we going to maintain all these computers that are basically on high alert to get going very rapidly from rebooting, or just simply shutting off, or doing something erroneous because the voltage dropped too low? Well, here's how they did that. They added a boost converter, a little device actually available in older hybrids. Used to be the fail-safe. That boost converter, all it does is it stabilizes the voltage. Basically a giant capacitor that loads up, and any fluctuation is going to make up for it, because we're only talking about a second or two. We're not talking about all day long. So they only need to stabilize that voltage for a second or two. That boost converter will keep the voltage steady while the battery will drop voltage-wise, because we're starting the engine. It'll keep the voltage steady across all other electronics, so you won't see a huge dip and things might restart. But then come the next problem, which was a serious one, the battery itself. Well, what if the battery gets weak? What if the battery is not able to start this engine? Well, we're just going to get stuck in traffic. So they started from the ground up, working on the battery and its system. It's not just the battery. First, the battery. They cannot put a normal battery, because a normal battery will drop as low as 7 volts when you start the engine. That's too low. The starter will slow down. That's just the way it is. So they put a special battery what's special about this battery is it's a battery that can hold high voltage when you give it high load, like the starter. So they did not want this voltage to drop below right around 9 volts. They needed things to stay up, so our capacitor would stay charged and be able to sustain. So in addition to the special battery, here's what they had to do to kind of monitor this battery, because what if gas station down the road didn't know that this car had start-stop technology, and they decided, oh, let's just get this regular battery, put it in, and we'll go. Well, actually, the computer, every time the starter starts, it's going to watch the voltage drop on the battery. If it drops below 8 volts, it's actually going to know that that battery is not the specified type of battery that we need, and it's going to alter the start-stop operation accordingly, because now we have a a battery that's not capable of these extended periods of start-stop events. So it's going to kind of change the programming and act accordingly. If this battery doesn't drop below 9 volts, we're good. We have a good battery. And if it starts noticing that battery degrading severely, like it's watching the amperage draw on it and how low it drops, it's basically doing a load test. That's what a load test is. It's going to supply a certain amount of amperage, start ramping it up until the voltage drops to a certain point. That's how the computer can calculate what's the health of this battery. So you notice on these cars, you'll actually have an amp sensor on the negative terminal. That's how they're able to do this. So the battery became a very vital point of this system, because without the battery, it could just shut everything down and not do any start-stop events. But then we arrive at this. They were able to shut off the engine. They were able to restart it because now we have a battery and a rapid start. But what about the event itself when we are in that off time? Here's the first problem they ran into, the HVAC. Let's start with the heater. Well, cars, gasoline cars and their heaters. The heater comes from the hot coolant, which is circulated by the engine water pump, which is mechanical. You shut off that engine, well, there's no coolant flow. If it's very cold outside, it's immediately going to be apparent that you don't have coolant flow. You're losing heat immediately. They did not want that. They wanted it to mimic a hybrid. Hybrids don't do that. They'll have heat always, even when the engine shuts off. So they put, in addition to the mechanical water pump, they added an electric water pump that it does not run all the time and does not run when it's 100 degrees outside. Only when the system deems that the inside cabin temperature is too low and the ambient temperature is too low, we're gonna need that coolant flow to continue. So it's gonna, when we have a start-stop event, the engine shuts off, it's gonna activate that little pump to keep the flow of hot coolant going. Now we're only talking about a short period of time. It's not gonna, of course, the coolant eventually will start getting cold, but we have enough reserve, the engine's still hot, for that coolant to continue to circulate, and you won't feel any degrade in the heater performance, which is pretty cool. But then what about our friends in the hot areas? And this is the biggest one. This is the one that Toyota, in my opinion, does it a little bit better than others. Some of them do it better actually than Toyota, but many don't. And that was the surprise. So the AC operation, I mean, you shut off the engine, the compressor stops spinning, you don't have refrigerant. It will take a second for that AC to get muggy and hot. That's literally how it is. So here's what Toyota did. The evaporator, again, in 30 seconds, here's how the AC works. This magical gas that is a refrigerant has specific properties. When you raise the pressure, you raise the temperature. When you lower the pressure, you lower the temperature. You create a restriction in the system. The restriction will drop the pressure down. That drop of pressure means less temperature. That is your evaporator. Air passes through it, it's very cold. The evaporator, the air will get cold. Then that comes back, very hot, because now it lost it's not cold anymore, because we took the cool from it. It goes back to the condenser to get cooled down, back to the compressor, and off we go. That is very, very basic AC operation. So that evaporator inside the car, you have refrigerant going to it all the time to keep it cool, so air will pass through it, and we have cold air. Well, when you shut off the compressor, everything just stops. And it is not like the coolant. This is rapid. It's almost immediate that this evaporator will not be cold anymore. So here's what they did, which is pretty clever. If you haven't seen an evaporator, here's how an evaporator looks like. Well, in between, basically, for lack of a better word, it is a fancy radiator. That's all it is. In between the tubes and the fins of this evaporator, they added a cold storage, like little plates. All these do is, it's a specific design plate that is designed to kind of lose heat and get very cold. Not freezing, but very cold. And they hold the cold more than the evaporator itself. So you have these plates sitting in there that got very cold. When the air is passing through, even though we lost the cooling from the evaporator, you're still getting some continuous cold air. Again, we're not talking about hours and hours. It's only a matter of 20, 30, up to a minute, 2 minutes, something like that. It's going to be able to sustain that AC operation while you're stopped and the engine is off. That one is really brilliant. The next problem was the automatic transmission. See, here's the way automatic transmissions function. They're hydraulic. There is mechanical stuff, of course, but the way it engages is hydraulically, and the way that hydraulic pressure is achieved is you have a big mechanical pump that is spun by the engine all the time, and that generates that pressure needed to apply the clutches and get everything going. But what happens when you shut off the engine? That pressure drops to zero instantly. It's just how it works. So by the time you restart the engine, it's going to take it a few seconds to build up that pressure again so we can get going. Well, that's not going to work. So here's what they did. They actually integrated an electric oil pump in the transmission that only applies pressure to only the certain clutches needed, or the bands, or whichever orientation in that specific transmission, to keep the first gear engaged. So when you come to a stop, you have a start-stop event, the engine shuts off, you still have the clutch held, you're still in first gear, ready to go. So we're not delaying things more until the transmission builds up pressure and let's go. It already has pressure and it's ready to go. As soon as the engine restarts and the mechanical oil pump takes over, that little electric oil pump shuts off. So that electric oil pump is not running continuously, it just runs when we have a start-stop event. And the last problem they ran into is the brakes, believe it or not. So gasoline cars, they have power brakes, and the way that most of them achieve power brakes is using vacuum from the engine stored in the vacuum booster, and that's what assists you to push the brakes. Well, when you shut off the engine, you kind of lost your vacuum. And yes, cars are equipped where the brake booster is big enough where it holds enough vacuum to have a few brake applications. But what if you lost some of that? And this is where they had to add a vacuum sensor on the booster to watch it, because if it drops too low, basically the car could creep from underneath you, and that is very dangerous. So they had to actively monitor the vacuum reserve. If it drops low, we're going to start the engine to fill that reservoir so you're not losing your stopping brakes. That is very important. Then the next thing they did all that and things started working. They were extremely happy, except this. If we go back to fuel-injected cars, did you know that the reason your car takes 2 seconds, 3 seconds to start when you crank it, every car will do that, is the engine needs to be at a specific firing position. So it would start from the beginning, and now we have figured out our crank position, figured out our cam position, and the computer can start taking over from there. And that's why you need a little bit of cranking to do a full revolution in the engine for it to catch, and then it knows where everything is at mechanically, and we fire. Well, if we did that every start-stop event, that'll work, but still not as... They're really bothered by that hybrids, how they just start and go immediate, because you have the big electric motors doing everything. So they took things with the fuel injection to the next level. That's the way I'm going to say it. Here's what the computer does. Here they didn't have to do a lot of mechanical change, but they really went overboard with the programming of the computer. So here's what the computer does. When you have a start-stop event and the engine stops, the computer is actually going to be closely watching the crank position sensor. What that is the sensor that picks up where is the crankshaft at, where is this piston at, where is that piston at, where is the cams at through the cam sensor. It's going to kind of freeze that image. Where did the engine stop? Let's say we stopped at cylinder number 2, ready to fire. When we restart the engine, it's going to immediately fire number 2 and kind of like put a pause and then resume. We're not going to have to crank the engine for 2-3 seconds. It makes it immediate. This engine will start immediately, exactly where it left off. That is so cool. And they actually did have, the only change they had to do is the crank position sensor, the signal became a little bit richer, more detailed, so the computer can really tell exactly where that engine is at when it shuts off. Not only when you give it the signal shut off, where it actually mechanically stopped, and then it would restart it exactly at that same point. That is, to me, and I'm sorry I might be a little car nerd here, that is the coolest thing that they ever did in this system. Now let's talk about the conditions or the moment the computer is deciding, should we have a start-stop event or not? This is a split-second decision that the computer will talk to every single sensor and computer in the car to make sure that we are safe to do a start-stop event, which is something very cool. Never was possible with older computers that were slower. It's only possible today because computers in cars have gotten very rapid. Here's what the computer checklist will be. Is my coolant temperature at the correct temperature? Because if the engine is too cold, it is actually not good to jar it with that rapid start and that freeze and continuation. It's actually not good for the engine. We need to richen the mixture, we need to do all this. We are not in ideal conditions for a start-stop operation. Then the next thing, same thing with the transmission. We do not want to jar that transmission when it's cold and it needs more pressure that little pump cannot reach. That's the other thing. And then it goes way more than that. Do we have any doors open? That's another thing, because are you stopped to open the door and talk to your friend or letting your kids off? We don't want that weird motion in operation. Is your seatbelt buckled, the drivers? Are we in a continuous driving? What the computer is trying to achieve here is, are you stopped at a traffic light or not? That's what it's trying to achieve. The only time you will stop in drive with your seatbelt buckled, with the doors closed, nothing happened, is at a traffic light. That's usually how that happens. Otherwise, you'll put it in park, or you open the door, somebody will come in the car, you'll take your seatbelt off. This is how the car determines. And then the next thing, which is very important, the HVAC. Are we demanding more heat than the coolant temperature is? Because it's very possible that that is the case. Are we demanding more cooling than the temperature of the evaporator? If we're kind of in extreme cold weather or extreme hot weather, are we going to be able, with all these modifications that we did, to kind of reliably sustain heat or cold? If not, the computer will not allow a start-stop event. And that's how it monitors. So it's talking to all these sensors at the same time to collect all these data to make a decision. Are we going for a start-stop or not? And it happens in an instant, in a millisecond. It can get all this data because it's always watching it. Now, the one limitation of this system will not operate in ambient temperatures below 23 Fahrenheit because this is too extreme weather for the system to operate reliably. So that's where they draw the line. It's like, we cannot operate the system under this temperature. Now, it goes a lot more than this because the computer needs to know the condition of the battery. That was one of the first things it checks, actually. What's the temperature of this battery? Is this battery overheated? Hot batteries and very cold batteries don't behave the same as optimal temperature batteries. How is the voltage? How was the last test of this battery? Do we have a special battery that is designed for this? Or do we have a regular battery that is not designed for this? It's going to do all these calculations and all these checks in a matter of milliseconds to decide, are we shutting this car off or not? And before, if we were talking about humans sitting down in a giant table making this decision, by the time they start talking about the first subject, the traffic light already turned green. So this happens in an instant. The computer decides we have a go for a start-stop or we do not. But then there are multiple conditions where the system decides, no, we're not doing this. And in Toyota, they will display the reason. Many other manufacturers will, some of them won't, but it will actually tell you why you don't have a start-stop event. If there's any malfunction in any of the systems in the car that contribute to the system, it will not allow it. If you have any warning lights, it will not allow it. If the temperature is too cold, if the battery is too weak or is charging, it'll actually say battery charging. If your HVAC demand is too high, you need too much heating, too much cooling, it'll actually say it. All these factors, the computer have to decide in a millisecond, are we a go or are we not a go? Now, what are some possible complications? I mean, most people will look at this but like, wait a second, this is way overcomplicated. Is this going to make my car less reliable? Problems, and some people have said this causes engine damage. Well, let's talk about a few things. Yes, there is one thing that becomes a casualty of this system, which is not something you should be very concerned about, but hear me out here. The starter, that starter We cannot just wait for that starter to seize up and die in the middle of a start-stop event to realize, hey, we're in really bad situations now, we're stuck in traffic. No, they actually realized that we should put an end life of this starter. And in Toyotas, that number is 384,000 start-stop event cycles. When we did the math, if you drive your car between 15 and 20,000 miles a year, you're talking about just over 10 years of day driving, continuous use, every single traffic light, you're using that start-stop. It's over 10 years. I mean, most cars, 10, 15 years, it's not such a bad idea to replace a starter preventatively. Some of them probably not because they're very expensive, but most average car, that's about how long a starter lasts anyway. So they figured we're gonna put a timer. It's gonna count from when the car is new. One thing you need to know, when that starter actually reaches that life, it's gonna set a code and it's gonna disable the start-stop system completely until you replace the starter and reset it. One thing I will warn about, do not reset your starter counter without replacing the starter, because you could create a very dangerous situation if this starter was not replaced and you told the computer it was replaced and it started the counter again, and then you're in the middle of a traffic light, it shuts off and you won't be able to start the car. That could create an accident. Be very careful. That's not something you should be doing. The next thing is the battery. So the battery for these cars is a special battery. It's a specific type of battery that can withstand this load, and it is a very expensive battery. But the good thing is, folks at Toyota designed it so you can use a regular battery. It's just that the system will react differently once it picks up that this is not the special battery that it needs. It's gonna decrease the time that the engine is off, and it's gonna heavily monitor this battery more to make sure we don't get ourselves in a situation where the battery is too weak to start this engine. So that is the good thing. But the thing is, every time you replace a battery, you actually have to go in and tell the computer. Ideally, you'd want to do that, even though after some time it'll pick it up, but it won't pick it up after a day or two. It's going to take a long time to make sure we understand what this new battery is, but it will immediately know that there is a new battery just from the way it's behaving. And the last thing is, which is very important, some folks have mentioned that the start-stop system actually damages the engine. Folks, that is not true. Not true at all. There is no data, there is no evidence of this is the case. Some cars have hundreds of thousands of miles with the system regularly operated. Nothing happened to the engine. The only way the system would actually damage the engine is if you have repeated start-stop events when the engine's cold. That's actually not good for it. You're running weight rich and you'll have that lingering fuel around. But here's the thing, the start-stop technology system is very smart. I mean, it's watching all these things. It will not allow that to happen. It will not shut off an engine that is very cold. It'll wait for it to get to optimal operating condition before it does that. So really, that's the only case, and that's a no case because the computer won't allow it. So as you see, the system is a little bit more than just shut off the starter and start it again. And again, folks will say this is way overcomplicated to achieve nothing. It doesn't achieve nothing. It can be annoying. I'm with you. I understand. And the number one question that everyone asks, can you permanently disable the system? Can you just make it to automatically be off when you start the car because you have a little button to disable it? Folks, this is an emissions device. I highly suggest you do not alter it, you do not modify it. As a shop owner, it is actually a big problem to alter an emissions device. You should not alter it, you should not modify it, you should not change it. That's what the law says. What you do to your car is up to you. But if you don't like it, hit the button every time you start and it won't do anything and will not operate, and that's about it. That's how the future is going. There was times where people dislike fuel injection. Whoa, why could we just have a carburetor? Why do we have to have all these wires and electronics? But that's how life moves on, and we have to kind of advance with it. And this is the new technology. It is for emissions. It does work for emissions. Not really for gas mileage very much, but it does work for emissions. And things are changing with cars. We have to change with them and adapt and move on forward. Folks, I hope this video was helpful and informative. I hope you learned something new. If you like it, consider giving it a thumbs up. If you're not a subscriber, consider subscribing to the channel. Check out some other videos. And until the next video, folks, may the Lord bless you and keep you, and you have yourself a wonderful day.